It's a pleasure to be here today to talk to you about the language of math. I started my career, as you heard, as an elementary teacher. I started in kindergarten, I like to say, and I worked my way up through the university. I taught at high school for 10 years, and when we were there, one of the things we kept asking ourselves is how do we get, I taught at newcomer high, which was for newcomers who didn't speak any English, and they spent the first year at our school and then transitioned to the regular academic high schools. And we're always trying to figure out how do we leverage the math understanding that these kids come with and give them the English they need so that we can kind of jumpstart them and be able to do the required stuff that was going on in their math classes. So I have no direct experience with math, although I've worked with a lot of teachers who teach math. And I appreciate everything you do. Basically, I think it's marvelous because I could never, ever do it. All right, but on to the language of math. Our goal today is to examine the role that language plays in the new Common Core standards, and to that end you have a document in your handout that we're going to pull out in a little bit that talks about that. We're going to identify math language that supports mathematics in the era of the Common Core. I'm just going to quickly do this because we don't have a huge amount of time. And then I'm going to talk about a few ways that we have been fooling around with at Stanford on how to get kids to use language in academic settings. Okay? So the first thing I want to just kind of go over is something you already know, which is the big shifts within the Common Core call for opportunities for students to participate in different mathematical, and I forgot to change this word, but we're going to call it interactions and practices, and you'll find out why in a little bit. And also we want to support mathematical discussions by providing students with a number of structures. And by structures, I don't mean English language structures per se, although that's not a bad idea for kids that are very beginning. But what we're talking about is ways that they can interact. And then we want to also focus on students' reasoning, not just on their flawed language. Students can say a lot of very good things in English that is not very correct. So we need to recognize that and then help them to perfect their language while they're perfecting their reasoning and their understanding. Okay. I just want to point out that the website for understanding language, I'm getting a lot of feedback. Where am I standing? I shouldn't stand. The website for understanding language is ell.stanford.edu. On that website, you will find 4 math lessons, and what the people there did was take the Mars units, 4 of them, 1 at elementary, 1 at middle, and 2 at high school, and actually look at them and say, how can we make sure that kids are using language at the same time that they're doing these Mars activities? So you can take them down as exemplars. They're meant to be exemplars. If you want to teach one, that's fine, but the idea here is not so much that you teach that unit, but that you look carefully at how they've incorporated language as part of the math expectations. There are also there's some 20 papers or more up there. A number of them, Phil Darrow, who you're going to talk today, I think has a paper up there. Also, there's a number on how to get kids to interact. And so I've put a couple of those up there. We have instruction for diverse groups by Leo Van Leer and Aida Walke, which really talks about how to get kids to interact, and the same thing for Aida and Margaret Heritage, who I think works here at UCLA, talking about how to get kids talking in class. Okay. Where am I? Here we go. So, what's this all about? Mathematically proficient students understand and use stated assumptions, definitions, and previously established results in constructing arguments. They make conjectures and build logical progressions of statements to explore the truth of their conjectures. This is what you, as math teachers, are expected to get kids to do. If I stand over here, I'm in front of the thing. Expected to get kids to do as they're developing their math skills. So, let's look at this in a different way. The old way of thinking about language and math was you have language, you have math, and mostly you're talking about building kids' vocabulary and some of their grammatical structures to be able to talk about the language, the problems that they're solving. Okay? With the Common Core, this is what you're going to do. And this comes right from the Common Core. We're going to talk about extended discourse and talk. So students are going to have to talk a lot about what they're learning. They don't just say one word, they don't give a one-word example, they give lots of extended discourse about why they think it's that way. They're going to discuss complex problems and break them down orally with each other. They're not just going to kind of figure this out in their head. They have to give explanations for why they did what they did. And sometimes it's wrong and sometimes it's right, but the explanation is what you're going for here, not necessarily the right answer. Initially, I know you do worry about the right answer. We also want to talk about constructing arguments and helping others understand their point of view. They're going to make conjectures. They have to learn to read complex sentences. Dr. Lily Wong Fillmore is doing a lot of good work in this area, helping teachers understand how to read complex sentences. And I think if you can Google her and see some of the things she's done. And they have to state assumptions. And finally, they need to know some vocabulary, but vocabulary in context. They don't need to know, lists of words. That doesn't work. So basically, these are the demands now in terms of language for all students. And you can see these are really a big demand for English learners. So what are some of the things that we know about math? Well, the language of math. Basically, in terms of vocabulary, we know that math has a lot of multiple meaning words. That is, you use the same word to talk about the same operation. So if we're talking about adding, we have add, plus, combine, put together, increased by. Okay, so all of these terms would refer to an operation. Or subtracting, we have decreased by, take away, minus, less. One of my favorites is multiplication, where we say something is 2 times something else. Well, times implies multiplication, but it also implies a lot of different things in different subject areas. So kids have to learn a whole way of understanding common words that they're used to using, but how you use them in math. Also, common words for specific meanings, such as set, point, field, table, plot. And these are things that as English learners get tripped up on all the time. So if you have a table, their most common use of table, of course, is that thing that's sitting right in front of them. But when you're talking about it, you're talking about a graphic in the book that's demonstrating something. So those kinds of changes need to be explored. Also, we need to talk about some pretty complex words that do directly need to be taught. So you have coefficient, exponent, least common multiplier, so on and so forth. These kinds of things are parts of the language of math that need to be taught. When we talk about syntax in math, what we're talking about in terms of word order is very complex. No other subject has more complex sentences than math. When we look at them, we have things like, by what percent is 16 increased to make 24? Even as an English speaker, that's a convoluted sentence, you know. So helping kids kind of unscramble those sentences and make them into what we would say is a more formal kind of, regular kind of English is really important. The other thing math does, and this is not common just to math, all subjects, is they use the passive voice. And that's something like, 10 divided by 5 can be renamed as 2. Okay? But it's not talking about who. There's no agent, there's no person doing this. So one of the things you need to help kids understand is that passive is always very, very difficult when you're talking, because they're used to the more straightforward person, subject, object. Finally, we have multiple clauses, and you have huge sentences and word problems that involve lots of clauses, and it's very hard for English learners to kind of follow those clauses. Here's one small example. The chart shows that the maximum amount of 3 pollutants, and then the word that is actually something I put in there because that's not in the real problem. A light-duty truck may emit per mile. So these are I can't even say them, let alone understand them. So these are things that make it very difficult for kids. Finally, the other thing that makes it difficult, I didn't change the slide. The other thing that makes it difficult is logical connectors. You do a lot of if-then. If this happens, then that can happen. For example, consequently, these kinds of words are very common and need to be kind of taught. Lack of one-to-one correspondence between symbols and words. So this is like the number A. Now, first of all, that's not even a number, okay? But the number A is 5 less than the number B. Okay, so for English learners, they've just learned the alphabet, and now you can see where the problem is. Basically, reference, so 3 times a number is 2 more than 2 times the number. You can see how convoluted this language is and makes it very hard. So, just so you know. All right, so right now, talk to your neighbor. Quickly, I'm going to give you just 2 minutes to do this. What are you doing now to ensure English learners achieve and understand some of those linguistic forms that I just showed you up there on the thing? Go ahead and talk to your... Thank you. Okay, I at this point you're too big an audience to have you reply back, but I hope you're starting to think about what is involved in teaching the language of math. It's actually very complex. This is not that I want you to focus on all those small, discrete point things, but I think you need to understand them in order to move forward in terms of getting kids to interact with the language. What I am going to talk about today is something called the English Language Proficiency Development Framework. This is the document that you have in your folder, and I would like you to pull it out as we go through it. It's green, or what color is it? Yeah, it's probably right on front. You have page 20. It starts with page 20, and it says the math practices from the Common Core. It's that one right there in front. Right? No, the other one. Ah. Could you just hold that up so everybody can see? The visual. There we go. Okay. Thank you. Now, this is the document that was commissioned by the CCSSO because what they were worried about is they really wanted to know if you have these higher demands, then what is the language of language arts? What's the language of math, and what's the language of science? So this document, you can go online, you can download it, it's completely free, get the whole thing, was actually meant for people who are writing standards in the states. The CCSSO actually is just the chief instructional officers from the 50 states. So there's only 50 of them, and of course all the people that come with them. And they basically set policies. So what they wanted to do was make sure that the policy was set that we know that English learners, for instance, can't do this without any kind of support. So what is the language of math, and then how do we support kids to get there? So involved in the skills, one of the things they have to do is be able to identify the key points. That's a listening activity that another student is making. They need to elaborate on ideas in a group setting. They need to evaluate complex problems, which is reading and understanding, and they need to construct effective arguments, which would be speaking and writing. So actually, now in math, you're going to be doing listening, speaking, reading, and writing, which you've probably always done, but even more so at this point. Okay? So what we want to know is essentially how do we effectively employ a second language, in this case for English learners, which would be English, while learning through that language. So they're doing two things, right? They're learning the language and using that language to learn about math. So the states adopted a more rigorous academic, but what happened was they then used this document, the ELPD framework, to then construct the ELA, English Language Proficiency standards for the state. And California got in early on this train so that when they were writing the new standards, they were using the document you have in your hand to write the new English language development standards. So we know for sure that the new English language development standards are aligned closely with the Common Core. The way the document is set up, there are 4 parts. The first part is what is the language development theoretical standards behind what we're saying you should do, right? So that's the first piece, and that's kind of interesting. You can find it when you read it. It's pretty theoretical, not something very useful to classroom teachers unless you're doing a paper. The second part is the progressions, and the progressions are how things should be organized based on the theory. If you have this theory of language, then what is it that you need to do to make sure that kids are accomplishing it? The 2 things that we're going to talk most about today are the standards match and the classroom match. How do you take these key practices that are part of the Common Core and make them real for kids? And then what do you do in the classroom to make that happen? So all of that is part of this ELPD framework. So the part that we're going to start with is the standards match, and that's what you have in your hands there. We start with the key disciplinary practices, and in math there are 8 of them. Am I right? Yeah, 8. And so when we wrote this, what we did was we said, okay, well, if this is a key practice, then what are the analytical tasks that kids have to do? And then what's the receptive language and the receptive language? So what you have here then is and the document will have English language arts, which is this one, and you see there are key practices for English language arts. And then we have the math, and this comes right out of the standards, the Common Core standards. You have the 8 practices for math, and then some of the ideas, classroom ideas. And then you have science. And what we did at Understanding Language is put this onto a big kind of Venn diagram so we could see where the overlap was. And what we see is that in the center here, we have a lot of common activities, language activities, that go on with your colleagues in English language arts, science, and social studies. So we're going to build strong content through knowledge. Okay, everybody does that. We're going to comprehend as well as critique. That's new. That's something new for the standards. Not that teachers never did that, but they're going to be doing it at a far more comprehensively across all subject areas. Value evidence. They're going to reason abstractly and quantitatively, construct viable arguments and critique reasonings of others. From science, we have engage in argument from evidence, but that's also something you're going to do in math. Construct explanations and solutions, obtain and evaluate and communicate information, use technology, and use appropriate tools strategically. So these are the things in the middle here that are probably the most common across all subject areas. And where in your PLCs, if you're doing that in your school, basically you should focus your attention, because the more bang for the buck. If everybody is talking about argument and how to construct an argument, whether it's in math or social studies or science, essentially the kids get it if you do that kind of coordination across subject areas for them. So when we look at math then, the pages, if you turn to the second page, you will see how this is put together. The first practice, which is make sense of problems and persevere in solving them, is laid out there. And under that, you will see the analytical task, the kinds of things kids have to do to get to that standard, that practice, right? So they have to explain to themselves, how a problem's meaning and look for entry points to solutions and plan solution pathways. That's what they have to do. That's a task, something they do. Now, when we look at the language that they have to do, you see that they have to comprehend the meaning of a problem as presented in multiple representations, such as either spoken language, written text, diagrams, drawings, and they need to comprehend others when they talk about the problem, and they need to coordinate text and multiple representations. So this is what they do in a receptive level of language. In an expressive level of language, to show what they can do, they need to concretely describe and use, presenting solutions to math problems. They need to explain a word problem orally or in writing, and the relationship between the quantities and multiple representations. So they need to do these things verbally. So you see how this chart is set up? And for each of the key practices, you have the same thing. You have the analytical tasks, you have the comprehension, what is it they have to understand, and you have the expressive, what is it they have to be able to say or do or write, okay? So that's kind of how each of the practices is set up within the document that you have right there. Okay. The classroom match then talks about how, I'm going to get off this, we're going to do something a little more practical in a minute, but I want you to understand what you have. It talks about the functions of language. So first we have the modality. What way is language used? We have the registers. This has to do with appropriate language for the person that's speaking. And then we have examples of arguments. So in the area where we have specific, oh, that's a different handout, I think. Or did they put them together? Okay. Last page. Essentially, you can see that there are different modalities, the different ways in which we use language. And what we did was kind of break it down by what the teacher does and what the student does, because that's important. We don't want you talking the whole time. We want the kids to talk. So that's why you have it broken down both ways. Okay? So I'm not going to go into this because I think it's pretty self-evident what this is. I mean, how we do this. Here's a little closer view. You can see the oral production here. And then again, we have the receptive, what kids have to understand. And this column has the productive, or what kids say or do. So these are just examples. They're not meant to be the end-all of math language. Okay. I'm going to show you a little video of a math classroom. This comes from the teaching channel. And what I'd like you to do is turn back to the page on practice number 1. I think that's page 21, is that right? I think so. And what you're going to do is, with your partner, one of you is going to take notes, or you can just check off on your checklist there, ways that the students build on each other's thinking. And the second one, the second person in your group, or group of 2 or 3, is to take notes on the way the students use the language of math. When do they actually use math terms, okay? So you're just going to kind of take a few basic notes so you can talk about it later. Okay.
Because 300 divided by 3 equals 100, and 120 divided by 3 equals 40, and we just add the answers.
So I'm teaching them how to think. I'm teaching them how to explain their way of seeing this problem. And if they can all understand what they're all saying and realize that you can model this in fractions, you can model it with an array, or you can do computation, and you all end up with the same understanding, that's like 3 times as good as having just the right answer. True or false? The kids love true false because they've gotten to the point where they like to have debate. Now remember, if you think it's true or if you think it's false, you want to have a really good reason. Okay? There are times when paper and pencil come out, where drawings get made, examples get made, they model, they'll pull out manipulatives, they'll say, look, if we do this. So what they're trying to do is help the other person understand their way of seeing it, and then the person they're talking to, if they're not convinced, will do the same thing back. 80 divided by 4 is the same as 80 divided by 2 and 80 divided by 2. I could put a story problem around this. 80 Skittles divided by 4 kids is the same amount as 80 Skittles divided by 2 kids plus 80 Skittles divided by 2 kids. I want you to think carefully. Remember, you need to have a reason that you think the way you do. Go ahead.
I think it's false. I think it's false. It's true because if you switch it around, 80 divided by 2, and then the other one, 80 divided by 2, it's true.
It's very evident that the rigor of learning for the kids has increased. And it has also increased the rigor of teaching. But they are responding to that, and they're being successful with that. And then the benefit of that for them is that they feel like they can do anything. Show me a thumb if you think it is true. Show me a thumb if you think it is false. So we have some people that think both ways. So let's take some people who want to support false. Let's start with Jason. Would you defend true?
Because you're cutting it in half 4, so it's 80 divided by 2. And then it's another 80 divided by 2 because 2 plus 2 equals 4.
Okay. Romy, what are you thinking? You're agreeing.
I think it was true because 2 plus 2 is 4, so then it'll be the same thing.
Okay. Kaya, what are you thinking?
What I'm thinking was that 80 divided by 4 is 20, and then you have the equal sign. It's 20 is the same as 80 divided by 2, which is 40, plus 40, which is, it's false because 40 plus 40 is not 20, it's 80.
Go ahead,
I
Vivian.
think it's false because if you do 80 divided by 2, then you already splitted all the Skittles, so you can't do it again because all the Skittles are already gone. You can't change the divisor, you can only change the dividend.
So what do you think, Jason, about what she said? She said if you split 80 Skittles between two people, you've used them up and you can't do it again.
I think she might be right, so I'm starting to think it's false.
So you're starting to wonder. Okay, the increased rigor of the Common Core and of what we're expecting them to do as a matter of practice, they're more than happy to explain what they think to anybody who asks. And that sort of confidence, along with the content knowledge that they're learning, is preparing them for middle school and high school in a way that we have never seen before. Did you revise your thinking? Did we help you revise your thinking? Right. It makes me want to come to work when the kids are that encouraged and that excited about learning. They realized finally how hungry they are to know more, and that they can make sense of it is the most empowering thing in the world. Clap once if you can hear my voice. Clap two times.
Okay, turn to your partner. I'm going to put those back up. What did you see in terms of language? What were some of the things that how did they build on each other's language, and also how did they talk about the language of math? Just talk to your partner about that. Okay, so what do we see? Did we see the kids using the language of math? Yeah, especially at the end, the little girl that was talking about the denominator and so on. But the other kids, were they actually using the language of math? Yes, they were talking about the topic. And one of the things we want to make sure is that we understand that language is a continuum. It's not, we used to say that language was, we would say that, you have conversational language, everyday language, and then you have academic language. What's really shifting in terms of the field of ESL is that we don't look at it that way anymore. We see it all as a big continuum, and sometimes it's appropriate to use conversational language within the classroom to talk about academic stuff, as well as other times you want them to sound more like mathematicians, so you want them to use the actual language of math. So think of it that way as a continuum. And some kids are going to be further along that continuum, as was evidenced in this video, right? Some of those kids were actually very kind of sophisticated in terms of the way that they were using language, while others maybe were at a beginning point. So we need to think about how to move all kids toward that point of being able to talk about math in a way that might be more like a mathematician. The only reason to do that, of course, is to be clear when speaking about a problem, but it's also in terms of the new assessments, because the new assessments are going to be looking for kids to be able to do that kind of discourse, that kind of language. So I show you this as a way to kind of think about the kind of language that's going on and how to get kids to do it. The other thing I think this video points out very well, who did all the work? The kids. Too often I go into classrooms and who's doing all the talking? Teacher, right? You don't need to talk. You know this math, okay? They need to talk. They need to know how to do this. So shifting that conversation over to them, allowing them the time to process it, whether it's right or wrong, and then to try and convince each other, as you saw going on in that video, is really what we want to do. Now, do you think that little boy is completely convinced that he was wrong? He said no. I said, I'm kind of maybe thinking that he needs more evidence. He needs to be shown. And that's where the teacher would come in and actually show it. So I think these are the things to think about. How do you get kids to kind of start that process? And then is the time, I think, for teachers to come in and make sure everybody's on the same page and knowing how to do it. Okay. So That's the teaching channel video, but you just Google teaching channel. Okay, let's talk about discussion in a classroom. This is a little test. No, not really. But these are not in order, okay? You've got to match conversation, discourse, discussion, and talk to its definition, okay? Go ahead and talk with your friends, see if you can do that. Which is which? I just put this up because I think it's important to realize that the kinds of interaction that goes on in a classroom varies greatly depending on the task you give students to do. Sometimes we want kids to talk, to engage in a conversation where they are actually talking about their ideas and building on each other's ideas, right? I say something, you build on it, we build on it. It's kind of like building blocks. Other times, we want them to have extended discourse, which is more formal, where you've given them a problem and they stand up in front of the class and they're going to talk about how they got their answer, perhaps. Another thing is a discussion. A discussion can actually have a bit of debate, right? Those two kids that had different opinions, you could have them kind of talk it out in terms of why they believe this way, why they believe that, and try and get them to almost convince each other based on evidence. And then finally, we have just talk, where people kind of just speak themselves. I mean, they just talk about what's on their mind. Okay? So there are different kinds of conversations that we have, different kinds of discourse, different kinds of talk. And it's important to kind of start to figure out how those all relate and when to use which in the class. Okay? And Jeff Schweers is doing, this comes from his work, he's doing a lot with this. I'm going to share one little example. You have a single page that was passed out. It's called Constructive Classroom. And this comes from his MOOC. Kenji Okuda and Jeff did a MOOC in October, and they're repeating the MOOC in March 6th. So if you're interested, you might be, after we finish this, you might be interested in joining it. Yeah. A MOOC, online, I forget the real term, but it's an online course, webinar thing. Well, it's more than in this case, it's more than a webinar. What it is a course. It goes over a number of weeks. And this one is all about collecting bits of conversation from your students and then transcribing it and then analyzing it. We're going to do that right now. You'll see a little bit about what this course is. Plus, you'll learn a whole lot about how language works in the classroom. Okay, on your piece of paper, this is the problem. Context. During this 10th grade geometry lesson, which focused on geometrical relationships, students were asked to work in pairs, determine the length of a side of a square inscribed in a circle, describing the length in terms of r, the radius. Okay. The objective was for the students to apply their knowledge of the area using Pythagorean theorem. Thank you. You guys can say that better than I can. Describe the length of the side of a square inscribed in a circle. Okay? And the conversation prompt to the students was talk about ways to approach and answer the question, what is the length of the side of the squares given the radius of the circle, and justify your ideas. Okay, this is high school. You all have that. Okay, I'm going to put this up, and let's see if we can kind of do this. Somebody can, I need 2 readers. Can somebody project pretty loud? Somebody do this? Okay, good. 1, 2, the 2 of you, okay? Will you be A and you be B, okay? All right, go ahead and read for them.
It says to write down the side of the inner square in terms of r. What does that mean? There's no numbers, so we gotta just use r, I guess. We can measure it.
Okay, so go ahead and rate, talk to your neighbor. You're going to do 2 ratings. The first one is on building on the previous turns. Did the kids build? Did they listen to each other and build on what the other person said? Okay, so that's the first one. How did they do that way? Were they carrying on a conversation? Okay, and then the second, wait. I don't want to. Second one is in terms of the knowledge and skills of the lesson objective. Did they do what the teacher wanted them to do? And so you're going to give them a 1 to 4 scale on both of these items. So go ahead and talk to your partner and rate these. Okay, how many of you think that this was a 1? All right, on this dimension. Okay, turn taking. Okay, how many of you think it's a 2? How many 3s? How many 4s? Okay, interestingly, it was given a 4 because because more than half the turns in this conversation built on the previous. All you're looking at is not did they do it right. You're looking at were they building on each other's discussion. So whether it's right or wrong, I think 3, 4, those of you that did 3, I would agree with you too, because I think they could have done a little better, actually. Okay, but that's the thing. They're going to build on each other's talk, because when we put them in groups, what happens often? Yeah, one person does all the talking or the solving, or what else happens? Yeah, they talk about not what you're talking about. The other thing they tend to do is one person will just give his opinion, next person gives her opinion, and and they're not interacting and building on the knowledge. I once heard Jerome Harsky, who is a professor at University of Indiana, say that talking is the act about growing your own thinking. And I think that's true, right? When we talk, really talk, we may come into the discussion with some idea, but if we listen to others, we're actually changing and revising as we go. And that's the power of discussion within the classroom. Okay, here's the other one. How about the next element? The teachers, adhering to the teacher's direction. What do we give them? 1. How many think 1? How many think 2? 3? 4. Okay. That was actually rated a 2. Mainly because basically they didn't, even though they got the wrong answer, but this whole idea of it's kind of okay kind of thing really didn't answer the teacher's request that they come up with a way to find the length of the sides based on the radius. So I think that what we want to do here is start to look at classroom discussion in a way that helps you as a teacher understand what the kids are doing. And the way that Jeff Schweers in this MOOC do it is they just use old cell phones or some kind of interactive device, and they put it down, and while 2 kids are talking or a group are talking, and then they transcribe it. And they only want little snippets of discussion, not huge amounts, because you can't really analyze that. But if you look at it in terms of, are they interacting, building on each other's thoughts, and are they getting to the task that you've set out, you can actually get a lot of information about what's going on in your class. And like today we do this little group, and then we do that one, and then we do that. You just sort of move the phone around and use an old iPhone 1 or something, where they actually are recording themselves, and then you can take a look at the kind of interaction and see where the problems in terms of their reasoning are, and then also what's the language they're using. Are they using mathematical language to discuss these things? So those are just some of the ideas. Okay. Oh, here's the idea. I mean, we want to show that the kids are doing what their thinking is, and then we also want to show their growth in language. All right. So, one of the things I hope you take away from today is basically that ELs should not be removed from the challenges of the math class. Obviously, they're in your math class. They've got to learn the math. But they have to participate even if their language is not really strong yet. And kids can do that in a lot of different ways. If we had more time, I could show you a few other videos. Basically, we want instruction that builds on students' existing resources. So if they're going to do it in the primary language, fine. Somehow they have to figure out how to tell you it in English, but I always let kids start in the primary language if that's what they need to do, if they're so low in English, right? And then finally, instruction must immerse students in meaning making and language making, activities that build both the micro and macro language. And I think you've seen some examples of that today. I hope there's plenty more. We all are learning. We aren't there yet. I'm sure Phil this afternoon is going to have a lot of great activities. He's in the back for you. A lot of good information. I always enjoy hearing what he has to say. Thank you very much. I hope you enjoy the rest of the conference.